To find the number of diagonals in an n-sided polygon, we can use a formula using combinations. But I'm going to start off with a 5-sided polygon to show you how we get that formula. And so a 5-sided polygon will have 5 vertices, which I have named A, B, C, D, and E. In drawing a diagonal, I will need 2 vertices. First, I'm going to find all the ways that I can join 2 vertices. I can join one, if I start at A, I can join one from A to B. And then I can join A and C. And then I can join A and D. And lastly, I can join A and E. And so I had 5 vertices. They can be joined by drawing a line from one vertice to the other. Now, yes, you would say that this particular A to E is not a diagonal. It's just an edge. A to D is a diagonal, A to C is a diagonal, and A to B is not a diagonal, so we're not going to be counting. But for this particular example, I want to use all of the vertices. That means that I'll be including the edges and the diagonals. Okay, now I'm going to start at vertex B and draw the lines. But if I start at B, I cannot draw a line to A because I've already drawn a line from A to B. But I can draw a line from B to E. And also I can draw a line from B to D. And yes, I can draw a line from B to C because there was no line there. If I start at vertex C, I can't draw a line from C to B because I've already drawn a line from B to C. Can I draw a line from C to A? No, there is already a line from C to A. I could draw a line from C to E. And I can draw a line from C to D. If I start at vertex D, I can no longer draw a line from D to C. I can no longer draw a line from D to B. I can no longer draw a line D to A, but I can draw a line from D to E. When I get to vertex E, I cannot draw a line because all of them have been already drawn from one vertex to the other. Now, let's count all the lines that I have drawn. If I start from the edge, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can join all the vertices together 10 ways. Now this can be done using combinations. I have 5 vertices and each line is joined to 2. This can be written in a number of ways. We can write it combinations, denoted by the letter C, with a 5 on top and 2 below, which means that we read it as 5 choose 2. It can also be represented as 5, letter C, and 2. And often it's just written with brackets 5, 2. And so this is written as factorial 5 over 2 factorial 5 take 2 factorial, which is 5 factorial over 2 factorial multiplied by 3 factorial. If I expand that, that will mean it's 5 times 4 times 3 times 2, and I divide this over 2 times 3 times 2. Now the 2 and the 3 can be cancelled, and we are left with 5 times 4 divided by 2, which is 10, which is precisely what we counted. But here's the rub. We are told to find the number of diagonals in the n-sided polygon. Now, in this polygon, we have found that there are 10 not only diagonals but edges. So we need to deduct the number of edges. In a 5-sided polygon, we have 5 edges. And so the number of diagonals is that combination of 5, choosing the 2, minus 5, which is the number of edges. So will this work for hexagon? A hexagon has 6 vertices. Using the rule above, a combination of 6, choosing only 2 because it always has to connect to 2 vertices, and take away the number of edges. In this case, it will be 6. Let's work this out. C62 means a factorial for 6 over 2, and we need to take away 6. So this will work out to be 6 times 5 times 4 times 3 times 2 divided by 2 times 4 times 3 times 2. And the 2 and 3 and 4 can cancel out. We also take away 6, and the result of that will be 30 over 2 is 15. 15 take away 6, which is 9. And I'll draw all the diagonals and count them. It's getting a little bit harder to count them, but I assure you that there are 9. So if it's getting harder to count them, what would happen if I wanted to find out the number of diagonals for an n-sided polygon? So for an n-sided polygon, the number of diagonals would be a combination of n vertices. We're always doing it at 2, choosing 2, and we always must remember to take the number of edges. In this case, it'll be n. Finding combinations is made much easier if you have a calculator, and you can use, for instance, Casio. In the run mode, just press the option button, then press F6 button. In the menu, you will find probability button, which will be F3. You should now see the combination menu. If you are interested to calculate C62, you would press 6 first of all, and then you will press the F3, which will give you access to the combination, and then you'll press 2. and press execute, and this is what your screen should look like. I hope that this was helpful to you, and if you did find it helpful and you would like to get more of my videos, then please subscribe to this channel.